applying systems of linear equations. So we're talking about systems of linear equations where we have two equations and we're trying to find one solution that makes both of them true. And we've talked about a few different methods for solving them. And we're going to take a look at how are you going to decide which method you should use. And it really depends on what you see in front of you as the systems. So for graphing is good if you want to estimate. It's probably not good if you're looking for an exact solution, especially if that solution ends up being a rational number that's a fraction or a decimal. So graphing good is if we're trying to estimate, because again, graphing with human error might be off. Tends not to be my most favorite because it's cumbersome and time consuming, but it will work. Substitution works nicely if one of the variables has a coefficient of 1 or -1. We can solve for that variable and then substitute it into the other. Elimination using adding or subtraction. If one of the variables has the same, in which case we'll subtract, or the opposite, in which case we'll add coefficients. So if we see that we've got the same or opposite coefficients on one of my variables, elimination using adding and subtracting works well. And if none of these above ones work, well then I'm going to have to use elimination using multiplication. So if none of these work, this is kind of my last ditch effort. So we're going to take a look at a few systems and just decide which method do you think you might use. And there is some flexibility in here. This is kind of a judgment call on your part. So you might decide one thing and somebody else might decide a different thing. That's perfectly fine, but you should both come up with the same solution to that system. So I've got 5x plus 7y equals 2, negative 2x plus 7y equals 9. If I was going to solve this, I'm not thrilled about graphing. Substitution doesn't work so well because I don't have any coefficients of 1 or -1. But I do have two coefficients that are the same, so I could do elimination using subtraction. 3x minus 4y equals -10. 5x plus 8y equals -2. Again, graphing, substitution, I don't have any coefficients of 1 there. Could I get something to be a coefficient of 1? Sure, but that would be really ugly once I did it. I don't have coefficients that are the same or the opposites, so that doesn't work, which means I'm kind of left with elimination using multiplication. Since I have these two are opposites and 8 is a multiple of 4, it might be rather straightforward to take this first equation and multiply it by 2. That would probably work well. And then my last set here, 5x minus y equals 17, and 3x plus 2y equals 17. Since we have a coefficient of -1 here, this would probably make sense to solve for y and then substitute. Or, if you wanted to, you could take this first one and multiply it by 2, which would give you a -2y here, and then you could do elimination by adding. So again, I've got substitution here, but you might look at it and say, nah, not so thrilled with the substitution. Let's eliminate with addition, multiplying and then using addition. That's totally fine, again, as long as you're coming up with the correct solution. We're all good. All right, let's take a look at a word problem where we need to figure out which method we're going to use. So Jared has volunteered 50 hours and plans to volunteer 3 hours in each coming week. Clementine is a new volunteer who plans to volunteer 5 hours each week. Write and solve a system of equations to find how long it will be before they have volunteered the same number of hours. So my two variables here, I have how many weeks they've been volunteering, and that weeks is going to determine what their total number of hours are. So I've got weeks, W for weeks, and H for hours. So I have my two people here with parallel situations. So Jared, his hours are going to be a total of the 50 that he's already done, plus the 3 hours per week he's planning on doing. And Clementine, her situation, her hours are going to be just a total of the 5 hours per week she's planning on doing, because she hasn't done it any already, because she's a new volunteer. So when I look at these two equations, I see that the H and the H have they are the same. So I can actually, since this one has a 1, I can actually just substitute it in here. So I've taken my H here, and H is equal to 50 plus the 3W. So I'm going to take the H out of my second one and put 50 plus 3W in its place. You'll notice that if these two are equal to each other, then these two must be equal to each other also. So 50 plus 3W has to equal 5W, which we've got. We're going to solve for W, and I come up with 25 equals W. So that tells me that they will have volunteered the same number of hours after 25 weeks. And if I go back and plug that in, that should work. So 3 times 25 is 75. 75 plus 50 gives me 125. And if I plug in 5 times 25, that's 125 also. Again, these are really easy to check. If we were writing this as an ordered pair, it would be 25, 125, but that's not what they're asking. They're just asking how many weeks, not what's the total hours going to be when we're done. So I can just write this as 25 weeks for each. So again, taking a look at the system of equations that we've created, and deciding which method makes the most sense with the systems that we have in front of us.